In this video, we'll discuss how to find the payment value for an annuity due given the future value of the annuity. Now, the future value formula S of an annuity due to use to accumulate funds is given by the formula S equals to R, where R is the payment value times the quantity 1 plus I, where I is the interest per period. So another way to get I is take the annual interest divided by M, which is the number of times compounded in 1 year, raised to the N plus 1, where N is the total number of periods. Another way to figure out what N is, you multiply M times T, the number of times is compounded in 1 year times the number of years, plus 1, and then subtract 1 divided by I, and then minus R, where again R is the payment at the beginning of each period. Now, for this example, you're to find the payment that should be used for the annuity due whose future value is $55,000 with monthly payments for 12 years and interest rate is 5.7%. And we're going to assume that the compounding period is the same as the payment period. That means the number of times it's compounded per year is also 12 monthly. So for this problem, S, the future value is $55,000. R, the annual interest rate is 0.057 because it's in decimal form. T is equal to 12 because that's the number of years. And M is equal to 12 because it's monthly payment, so it's compounded 12 times in 1 year. So the interest rate per period is R divided by M, which would be the 0.057 divided by 12, which would be 0.00475. And N, the total number of compounding periods, is 12 times 12 because M times T, which would be 144. So plugging those into the formula, we get that 55,000 is equal to R times the quantity 1 plus 0.00475 raised to the 145 because that's the 144 plus 1, minus 1 divided by the 0.00475, and all of that minus R. Now the next thing to do is you notice the two terms on the right hand side both have an R, so we could factor out the R. So I factored out the R from both of those terms, so we'd have that fraction, the 1.00475 raised to the 145 minus 1 over the 0.00475, and I factor out the R from the last term as well, and if you factor out that R, you still have a factor of 1, so that's why we have the minus 1. Now all of that stuff within inside the bracket is just the number. You plug it into your calculator or computer, you get a number. So you'd have 55,000 is equal to R times some number, and so we'll divide both sides by that number. So when I plug all that stuff within the bracket into a calculator, I get that it's approximately 206.9959286. So I'm going to divide 55,000 by that number. So when I divide 55,000 by that number, I get that our payment should be approximately 265.7057091. So rounding that to the nearest cent. So the necessary payment value would be $265.71. Now if we wanted to figure out, we could figure out how much interest that this person would earn from this annuity. So the annuity is going to be worth $55,000 in 12 years, and what this person is going to be putting in is 144 payments of $265.71. So I take the 55,000 minus the 144 times 265.71, and I'd get $16,737.76. So that's how much money is made in interest.